Welcome to the third part, clustering with R. In the second part, we calculated the similarity matrix and we created a clustering object, and what we also did, we uh, we we also plotted the clustering object on an XY scale or in a 2D scale. Here I plotted it with sepal length versus sepal width, and here I said it's important to say as matrix, and here I am picking the first column and the second column with sepal length, sepal width. I could have also here when you say Windows, it means it start a new Windows. If you look at it here, I plotted sepal width versus petal width, which is basically I'm taking the column 1 and 3 sepal here, this one, sepal length and petal length, sepal length and petal width. This is column 1, column 2, column 1, column 3, sepal width, petal length, which I think this is will be sepal width, which is column 2, and petal length, column 3. Sepal width, petal width, which is column 2 and column 4, and the commands are here on how to do that, especially when the columns are not adjacent. You can look at it here. These are the commands to do that if you would like to. Basically, we can plot it any way we want as long as we are providing an x-axis and y-axis of the data points. Now, what I would like to do, I would like to start superimposing the different types of irises to see how do they fit into the clustering scheme. I know that if I go back in here, remember when we did our clustering, we excluded the species type, and I would like to see where are the setosas in here. Now what I want to do, I want to extract the setosas. How to extract the setosas? Remember when we said here, I'm saying here, if I say iris square parentheses and there is the comma in here. If you remember, we said I can put a conditional in the first one. I'm saying give me the iris species with a here. This is the dollar species. Give me the one where is equal to where species is equal to setosa. It means that it is going to pick the irises with the species setosa, and this will be from column 1. The same thing from column 2. It means we are excluding all of the other one, and the PCH is 8. It means this is the size. PCH equal 8 is a star. And if you do a question mark on PCH, you are going to see this in R. And if you look at it, PCH 8 is this one. Now, interestingly enough, when I plotted the setosas, I'm superimposing the setosas on the cluster. All of the setosas fit into this cluster. If you look at it, all the setosas data points fitted here, and none of them are in these clusters. It means this cluster is conclusive setosas, and the versicolor and the virginica are somewhere in here. If you run the command, you will be able to see what's happening. And remember here what I'm doing. Remember when there is a square parentheses, and comma, I can put row numbers here, or I can put a conditional statement. And this is what we did here. I superimposed the setosas in here. They fit into this cluster, and this is good. Now I want to superimpose the rest of them. Now I want to superimpose the versicolors on the data set, and I want the PCH to be 19. PCH equal 19. If you remember here, PCH equal 19 is the dark circle. If you look at it, now the versicolors are fitting into the green cluster except for one point. If you notice in here, there is one point which doesn't fit, and they are kind of dominating the pink cluster and probably some of the yellow and some of the blue cluster. However, the turquoise cluster or this cluster has no versi colors in it. Now if I keep doing the same thing, I issue the next command and I put the command here, and I took the PCH to be 21 and the background color to be red. If you look at it, you will get it in here. It looks like this cluster in here is all of it species, is all of it is Virginica, and some of it is in here. A lot of it is in here. The yellow one is mostly the other one, and these are the different clusters. This gives you an idea of how we are superimposing the points of the data set on the clusters. Now, I also would like to kind of like label them, the Setosa, the versicolor, and the Virginica, just label them for curiosity, so that if I am producing a graph, so that everybody sees what I am doing. Also remember, this is the sepal length, sepal width. I could have sepal length, petal length if I want to, and the code to do that. I here am starting a new window. By Windows, I think on the Mac you have to say quartz or something like that if you're using a Mac. Here I am plotting the matrix, then I am adding the points, and I'm adding, if you look at it, the setosas are PCH8, and here I am adding a legend with PCH8. Box.color, because when you add a legend it puts a line around the box. I don't want a line around the box. I am plotting the versicolors, and the PCH is 19, and I am plotting the Virginica, and the PCH is 19 and the color is red, and here is the color of the PCH will be black, here the color of this will be red, and this is what gets produced. And if you look at it, if I'm looking at my analysis, the setosas did very well. The Virginica did very well in here, and this was a mixed bag. What do I do next? Probably I will take these points out, and I will run another clustering to see if I can separate the other points better. Anyway, this is what you see. The other clustering algorithm which is the k-mean cluster. If you look at it, the AP cluster itself, really we don't have much control. In the AP cluster algorithm, we don't have much control on how many. There are other details I can control, but we don't control how many clusters. If you notice in here, if I say question mark, there are other knobs I can turn on and off. There are other knobs I can turn on and off when I'm doing the similarity matrix or the X input. Input preference, which is usually the quartile. If I'm going to use the mean as the exemplar, the median, the first quartile, second quartile, I think this is the quartile. This one is the quartile one that allows me to use which quartile I want to use. The 50th quartile is the median, the 25th quartile, etc. There are other knobs here, if you look at it, that I can control. However, there's no knob that says the number of clusters. Now, what I can do, I can run the k-mean cluster of the AP algorithm. Remember, the K is uppercase and the C is the C is not uppercase. The C is not uppercase. Let us see which one is the uppercase, which one is not. AP cluster K. Yep. The C is not uppercase. the C is not uppercase, the K is uppercase. It will calculate, here I can control the number of clusters that I want, and if I do that, here it is AP cluster uppercase K. I said K equal 2, and here I'm saying give me details, and give verbosity in terms of showing me what's going on. And if I plot exactly the same thing that I did in the AP clustering, here I said give me the two clusters, and if you notice here you can also superimpose the points that are on this cluster. Like here I am superimposing the cytosis. All of them are here. It means the Virginica and the versicolors are going to be in this cluster, and these are the color red is for the versicolor, the Virginica one. I called it Ver Iris 1 2. I'm plotting it, and the other one will be the versicolor. If you here I calculated them and I said plot the data points. Now if you look at it, here I'm running it with 3. I will get the same result. I will get similar results, but if you look at it, the same thing. It's always the irises are doing well all the time in this clustering. Now the next one is the agglomerative clustering, agglomerative or hierarchical clustering, and this is what I will be talking about next.